What's up, math scholars? It's Christy Harp here, and we're coming at you with a 10-1 to 10-3 video. The quiz is coming up Wednesday. It's open note, and so everybody should get an A on their last quiz of the year. Who's excited that the school year is almost over? Woo! Yeah, yeah! I knew I could get this quiet class enthusiastic. All right, so we're going to start with number 1. You have to come up with your key points for cosine. Now, your key points for cosine will always be the same. Let's start. It's going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, what I think to myself is, what is the cosine at all those different values? So in my brain, I'm thinking unit circle right now. The cosine at 0 is 1. The cosine at pi over 2, 0. Cosine at pi, -1. Cosine at 3 pi over 2, 0. And cosine at 2 pi is 1. So those are simply my key points that I now will perform my scale change. Your scale change is 1 over b times x with an a times the y. Now my a value is just 1, so that means nothing's going to happen with my y. But my b value is 2 pi. So I'm going to have to do 1 over 2 pi to all my x values. Multiply by it. So multiply 1 over 2 pi times all my x values. If I want to, I could talk about amplitude and period right now. Amplitude is just 1, and period is just 2 pi over b, or 2 pi over 2 pi, which is going to be 1. All right, so I'm ready to do all my scale changes. All my y's stay the same. 1, 0, -1, 0, 1. All my x's I will multiply by 1 over 2 pi. I tend to do that mentally, but if you need to show the work to figure it out, you can also show all the work. There'll be 0. The pi's will cancel, and the 2 times 2 will become 4. So that'll be a 1/4. The pi's will cancel, and it will become a 1/2. The pi's will cancel, it will become a 3/4. And the 2 pi's will cancel, it will be 1. All right, so 0, 1/4, 1/2. Oops, I don't know why I did that. I wanted to start the 0 at 0. Duh. 1/4, 1/2, 3/4, and 1. And I can do all my little dots. I start at 1, and then 0, and then -1, 0, 1. Connect with a smooth, pretty curve. And answer your final 2 questions that the domain is -infinity to infinity, and the range is -1 to 1. Here we go on number 2. This time our key points are going to be the sine key points. Sine key points will always be the same as well. They'll be different than cosine, but they'll be always the same for sine. 0, pi over 2, pi, 3 pi over 2, and 2 pi. So my brain is thinking of my unit circle and the sine value at all these different coordinates. So the sine value at 0 would be 0, because the sine is y value. The sine value at pi over 2 is 1, then 0, then -1, then 0. So it's one trip around the unit circle thinking about the sine values. All right, for my amplitude, it is 3. For my period, it's 2 pi over b. Now, if you're going to take 2 pi and divide by 1/4, it's the same as multiplying by 4, because you multiply by the reciprocal of the fraction you're trying to divide by. So your period's 8 pi. Ready to do my scale changes. My scale change, you do 1 over b times x. Now, 1 over 1/4 would be 1 times 4. So that'll just be 4. 4 times x. And then a times y, or 3 times y. So all these numbers are going to get much bigger. I like to do my y's first because they're easy. And now I'll do my x's. Everything's getting 4 times as large. So 0, 4 pi over 2 is 2 pi. Then 4 pi. This would end up being 12 pi over 2, or 6 pi. And then 8 pi. So 0, 0. And then 2 pi is at 3. 4 pi is at 0. 6 pi is at -3. And 8 pi is at 0. That completes my 1 period. Sine graph. Negative infinity to infinity for domain. Negative 3 to 3 for range. And that's it, I believe. All right, this time we're doing tangent. Tangent's a whole lot different, but almost easier, I think, because you don't have to do all those key points. The first thing I personally do for tangent is I figure out my period, and it's a different formula this time. Tangent formula is pi over b. So we're going to go with pi over 2 pi. The pi's will cancel, and the period will be 1/2. You do not put the 1/2 anywhere on the graph. What the graph has is asymptotes and halfway points. To figure out your label for your halfway point, you cut your period in half. And that's because the period actually measures from one asymptote to the other. So if this measurement's a half, then this measurement has to be half of that, or 1/4, and this would have to be negative 1/4. They could total up to the whole period. I'm going to rewrite that. All right, the next thing I'm going to do is figure out the halfway point. So it's halfway to the asymptote, or 1/8, and negative 1/8. So asymptotes are positive or negative 1/4, and halfway points are actually coordinates. So you'll go with 1/8 and negative 1/8. And the second half of the coordinate is the a value. So that's where the 3 comes into play, and negative 3. So you go up to 3 and down to negative 3. And you'll always go through 0, 0, tangent graphs. Where is your tangent graph? Make it as nice as you can. Get as close to your asymptote as you can. I'm not always super good at drawing these. Number 4 is our first one where you're seeing key points out of the wazoo. You're probably wondering, why are there so many key points? Well, I have a column for the original key points, a column for the key points after a scale change, and a column for the key points after translation. So you're going to end up doing a lot of work on this. Let's start with our key points for cosine. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Cosine starts at 1, goes to 0, and then negative 1 to 0, and 1 again. For your scale change, you're going to do 1 over b times x. Now, notice, b would be living right here, so there is no b. So that's going to be really easy. X will be unchanged. But for y, it's a times y. So it's negative 1 times y. So our x's will stay the same. That's easy. But our y's will all turn to the opposite. So it'll be negative 1 here, 0, positive 1, 0, negative 1. That's your scale change column. Now we're going to do our translation column. So you really just have to think about the shift. There's no vertical shift. If there had been, it would be on the far right. But there is a right pi shift. And to do something to the right, you will add that number to your x value. So all of our x values will be adding a pi, but all of our y values will be staying the same. Let me do my stay the same part of it. And now I have to add a pi to all of our x's. Some of these will be easy. That one will be easy, that one will be easy, and this one will be easy. But I was having a chat with Dakota. The other two, you're going to need common denominators to be able to add a pi. So to add a pi to pi over 2, you need a common denominator of 2. So you can make it 2 pi over 2 and get 3 pi over 2 for this one. And then for the 3 pi over 2, to add the pi, I also need the common denominator of 2. And I'll get 5 pi over 2. So it's fancy math on the denominators. The amplitude ended up just being a 1. You can never have a negative amplitude. And the period was 2 pi over b, so it ended up just being a 2 pi. Now this one's a little more challenging to get onto my graph. I'll make this pi, this 3 pi over 2. This will be 2 pi. This can be 5 pi over 2. And I'll extend myself 1 and make this a 3 pi. Go from negative 1 to 0 to 1 to 0 to negative 1. And I've talked about this before. I really don't like it. It's just weird to me to have a graph start here and not continue and touch the y-axis. So I would continue the trend and figure out that I would actually touch the y-axis at 0. All right, my group up front was kind of talking about the scale, and I was like, well, what are you talking about? And they were looking at my graph, and my scale was off. My pi was only half of a hash mark, but I had from pi to 2 pi as being 2 hash marks. So I had to erase and redraw my picture here. If 2 hash marks is going to represent pi, I would start my graph here, end it here, and to kind of work backtrack, that would make this touching at 0, pi over 2, and this would actually be touching at 1. So the reason I had to redo my graph is my y-intercept was incorrect the way I had it before I did my erasing. So sorry about that, and thank you so much. The kids were actually paying close attention to that. All right, last one for today, number 5. I'm going to do my key points for sine to get us kick-started here. 0, pi over 2, pi, 3 pi over 2, and 2 pi. For sine, you start at 0, go up to 1, back to 0, then to -1, then to 0. For this scale change, it does have a b and an a value, so we do have a little bit of work on our hands. It's going to be 1 over pi times x and 3 times y. So all your y's will get 3 times larger. All your x's will multiply by 1 over pi, which pretty much just cancels out all the pi's. Let me know if I did this correct. For our shift, that's going to be your translation. There is no horizontal shift. It would have been in parentheses, so there just is not one. But there is a vertical shift up 2. So that'll be a 2, a 5, a 2, a -1, and a 2. And all our x values can remain what they were in the second column. Amplitude 3. Period is 2 pi over b, or 2. Time to draw my graph in that. I'm going to go with a 1/2, a 1, a 3 pi over 2, and a 2. We'll start at 0, 2 for our y-intercept, head up to 5. 1, 2, 3, 4, 5. Head down to 2. Dip below the axis at -1 and finish at 2, 2. And I answered all the questions already. So I think we're gonna stop the video here and make a part 2 tomorrow with the rest of the questions.